Here is a concept map that I've created to help me summarize this week's key concepts and ideas and review the chapter with you now that you have completed your own collaborative online concept map with the others from your small group. As you can see, I've included the title of the chapter, The What and How of Statistics, which has been highlighted, in this case using a slightly larger font and the color different from the other colors that I've used in this concept map to convey a set of key clusters of ideas that I've drawn from the chapter. As with all concept maps, you'll see that the central idea, usually expressed as the title of the chapter that we are on from this course, is shown near the center of the page or sometimes near the top part of the page. Relevant key concepts are placed in rounded boxes, or nodes, that are connected with a directed line segment or arrow, and a propositional phrase is placed on the directed line segment to help us read the proposition. If your concept map is missing arrows, one cannot read your concept map properly. In other words, you ought to be able to properly read your propositional phrases as if they were sentences that have to make linguistic sense. Like me, you're welcome to use colors to distinguish important clusters of ideas that point to or reflect the structural elements in the text, like a heading and its accompanying section. This can be a helpful thing for you to do when you are reading through the course text. Last, although I do not do so here, as we move on to the next chapters, you may be tempted to include pictures or formulas in your circles. With that, let's have a look at this week's concept map, The What and How of Statistics. So as you can see, there are exactly 3 branches that come out of the what and how of statistics. Caldwell uses these, broadly speaking, as a way to cluster off the chapter into 3 main ideas. 1, we want to know what statistics is all about. 2, we want to know how it's relevant to ourselves and to you. And 3, what it involves. As students in a graduate program, you ought to recognize that grad school is going to be one of those areas where statistics could be quite relevant. Others, maybe not yourselves, but let's say you were involved in an internship or co-op program in your undergraduate days, you may have found that statistics were an important part of the work that you did. After you complete your program of study, if not now, you might find that you need statistics to do your job. Like myself, during my undergraduate days, I worked at an experimental farm, and I often helped the scientists on the research farm to analyze their statistics. And of course, since you've read the learning outcomes for this course, you'll know that being able to read statistical literature or articles is an important part of being a graduate student. So now let's turn our attention to the cluster of nodes or circles where I've used gray text to highlight the key ideas there. This collection of concepts reveals that there are essentially 2 kinds of statistical activities. 1, descriptive statistics, and 2, inferential statistics. If we start off with descriptive statistics and follow our concept map down from there, we'll see that descriptive statistics involves the use of population parameters and sample statistics. These 2 concepts are essentially the same, except that population parameters refers to some characteristic of a population, and sample statistics refers to some characteristic of a sample. Population is as it sounds. It refers to a whole collection of things. So, for example, the collection of undergraduate students at the University of Windsor. A sample, as you might imagine, refers to a subset of a population or a portion of a population. So, for example, a sample of the population of students at the University of Windsor might be all the students in the Faculty of Education. The last node in this collection of concepts refers to inferential statistics. And as you can see, and read along with me, inferential statistics draws upon a sample. It requires a sample. And samples, if they are representative of population, allow us to make certain claims about that population. Now over to the other side, the left-hand side of our concept map, where I have a cluster of nodes using a light blue text. Here we see some important key concepts or threshold concepts, concepts that are important to our understanding of the discipline of statistics. As you can see, statistics involves a collection of either information or data. This essentially means the same thing. We can use these terms interchangeably. The information or data that we want to use is often generated through a set of research questions or a research question. Part of being able to collect and then organize a set of data involves creating a data set. And you can think of a data set as being an array with cells that form a column or row, or something akin to an Excel spreadsheet. In our spreadsheet, you'll notice that there are columns and rows, columns representing different variables that we might have, rows representing different participants in our study. Our data set then consists of individual data values, and these data values can be numbers, they can be labels, they can be descriptions, they can be any number of things. Once you have your research question, you'll then need to identify the key concepts for your own study. This is a normal part of doing an actual piece of research. And once you have your concepts identified and constructs identified, you can then move on to identifying what your variables will be. A variable naturally is something that will help you to describe particular characteristics. This could be, for example, height, or sex, or eye color, or GPA, for instance. Once you have your variable collected, you'll notice that all of the values, all those data values for every variable, will constitute a particular kind of distribution. And if you were to graph a data distribution out, you'll recognize that it can have a particular shape. Or, if you don't want to represent your data visually, you can represent it tabularly, and so you can discern a frequency distribution. Last but not least, we move on to the orange-colored nodes and the attendant green-colored nodes. This is perhaps the most important part of the chapter, as there are a number of implications for the work that come in the subsequent chapters of our text. The key concept here for us to remember and know and understand is levels of measurement. The idea behind this concept is that there are different ways of categorizing or taxonomizing different kinds of variables. In statistics and quantitative research methods, there are conventionally 4 different kinds of levels of measurement. These are nominal, ordinal, interval, and ratio. The order of these 4 levels of measurement is crucial, as they point to increasingly complex characteristics for each of the variables. To help you remember the order, and for those of you who are linguistically inclined, if you pay attention to the first letter of each of these words, nominal, ordinal, interval, ratio, they form a word noir, N-O-I-R. This is the French word for black. Not that black has anything to do with statistics. Nominal levels of measurement are essentially labels. So for example, let's say you have the variable hair color. Naturally, you can imagine a number of different kinds of hair color. There's blonde, brunette, red, gray, white. There are a number of different colors. All the same, these values, these data values, are nothing more than descriptions or labels. There's not much that we can do with these data values. For example, you can't add a brown hair with a red hair to get another kind of hair color, well, unless you go to the hair salon. But arithmetically speaking, we cannot add different nominal data values together. And because we can't add them together, we also can't do a number of other things. But I'm going to stop there, as I don't want to get too far ahead of myself. You'll also note that ordinal levels of measurement are very much like nominal levels of measurement. These are also labels, but they have the additional characteristic that makes them rankable. That is, they can be ordered in some fashion. You've probably seen some examples. For example, if you've ever completed a survey and somebody asked you for your opinion on something, you could say very unsatisfied, unsatisfied, indifferent, satisfied, very satisfied. As you can tell, there's a range of choices starting with very dissatisfied going up to very satisfied, and each of those choices is ordered. The thing is, we can't tell what the difference is between very dissatisfied and dissatisfied, or dissatisfied and indifferent. Which is more? We can't tell. In this case, we say each of those classes, very dissatisfied, dissatisfied, indifferent, satisfied, very satisfied, are not equal, or the distance between those classes is not known. The third level of measurement is known as interval level of measurement. If you've been following the pattern along here, you might imagine that they'll be similar to the ordinal levels of measurement. And of course you'd be right. In this case, however, the classes are said to be equal. That is, the distance between classes is known and equal from one to the next. Let's use the canonical example of temperature. We know that the difference between 5 degrees and 10 degrees is a measure of 5 degrees. And in fact, it's the same distance as the temperature from 15 degrees to 20 degrees. You can even take smaller classes, say the difference between 5 degrees and 6 degrees. The difference there is going to be the exact same as the difference between 10 degrees and 11 degrees, or 17 degrees and 18 degrees. But let's take note of this particular value or measurement of 0. In this case, 0 is arbitrary. It does not signify the absence of temperature. The 0, in this case, is said to be arbitrary. And here is the characteristic that makes the final level of measurement ratio different from the interval level of measurement. When we measure a variable that is said to be of a ratio level of measurement, we know that the 0 in this case signifies an absence. One more point that is not on this concept map is that one can recategorize these 4 levels of measurement in other ways. One can categorize the nominal and ordinal levels of measurement as being categories or labels. With interval or ratio, these variables can be described as being continuous sometimes. So numbers that fall between the integers, so between 0 and 1, for example. There are a whole bunch of other numbers, as we know. And so variables like test scores, height, weight can be considered examples of ratio levels of measurement. Last but not least, if you've been following along, there are 3 nodes here that I haven't commented on. And those are the nodes that come off of the nominal and ordinal levels of measurement, their characteristics. If we consider the possible values for a variable which is at the nominal level of measurement, we know that those values need to be 3 things. They need to be mutually exclusive, they need to be exhaustive, and not too homogeneous. What does this mean? Let's say you were constructing a survey to give out to people, and you wanted to know their religious affiliations. If you were to construct a survey question where you only asked if individuals belong to a certain number of religions, you might miss out some religions. And if you don't include a line for other, then you would not have established a survey question which is exhaustive in nature. The values in your data distribution also need to be mutually exclusive. So for example, if your survey included the following items: Protestant, Episcopalian, Catholic, Jewish, none, other, it would break this rule of mutual exclusivity. With this example, there's some ambiguity as to which category I might belong to if I were, say, a Protestant or an Episcopalian, where both forms are forms of Anglicanism. On the matter of not being too homogeneous, with this example, Protestant, non-Protestant, we can see that to be a non-Protestant means that one could be Catholic, Episcopalian, Jewish, Buddhist, any number of things. And so as a category, non-Protestant, it includes way too many data values that are quite dissimilar from one another. Here ends my reading of our first concept map.